So we're going to continue to find all three of the perpendicular bisectors.
Mr. Frankie, I made it better.
Thank you.
You are welcome. Mr. Frankie, while you're doing this, can I ask a question?
Yes.
Alright, so when you have all three lines, should they all intersect and meet at one point?
Yes.
Great, I have to change it.
And that is called the point of concurrency. So where all of the lines intersect is called the point of concurrency. So you know you've done this right if all three perpendicular bisectors meet at one spot. Now here's the cool thing about the circumcenter. The circumcenter, and this is definitely within the definition of circumcenter, the circumcenter is equidistant from all of the vertices. So what I can do with the circumcenter is I can actually draw a circle such that it goes through every vertice exactly. So the cool thing about the circumcenter is the circumcenter is equidistant from every vertice in the triangle. And you find the circumcenter by creating the perpendicular bisectors. Now, obviously, since all three lines will intersect in the same place, you really only need to do two. So why don't you double check to see if it works.
Oh.
So it's a cool little trick.
Wait, so you draw a circle starting at the point?
Yeah, so you measure measure from the circumcenter to the vertice, and then you
Yep, it works.
Did it work for you guys at home? Did your circumcenter?
Oh, yeah.
All right. So again, that is called the circumcenter of a triangle.
What would the definition be exactly? We don't have like what we write down in our.
Simply, the circumcenter is equidistant from the vertices of all the triangles, of all the vertices of the triangle. And to create the circumcenter, you have to find where all of the perpendicular bisectors intersect.
Could you repeat that?
Sure. The circumcenter is equidistant from all of the vertices of a triangle. And the circumcenter is created by finding the point of concurrency of all of the perpendicular bisectors. All right, so then the next center that we're going to find is called the incenter. We're going to find the incenter. And again, the incenter is going to be found by a construction where we're going to find another point of concurrency. But this time, instead of finding the perpendicular bisectors, we are going to create angle bisectors. And let's see what happens when we find an angle bisector for each one of these angles. So put the metal point at the corner or at the vertice of the triangle. And we are going to find the angle bisector. So the first thing I'm going to do for the angle bisector is I'm going to redo that because I want to make sure these lines are nice and light. So the first thing I'm going to do is I'm going to create an arc that goes from one leg of the angle to the other leg of the angle. Are you guys with me so far, or do I need to give you some time to put the to draw your triangles?
1 second.
1 second.
Okay.
Avery, do you need time?
Yeah, I need 1 second.
Okay. All right. So once I find a point that is equidistant from the vertex, I'm going to make sure my compass is open where I would imagine the angle bisector to be, and I'm going to make an arc. Then I will, without letting my compass setting change, I will move my compass so that the metal tip is on the other intersection of my original arc and the leg of the triangle, thereby creating intersecting arcs. And then I am going to create a line using my straight edge that goes from the vertex through the intersecting arcs. And I'm going to extend it. Now, the incenter is never going to be outside the triangle, so I was a little ridiculous in my extending it, but that's okay. So I can keep it a little bit shorter. And then I will follow the same steps over again for my other two angles.
Mr. Frankie, the definition of concurrency is just where all
Yes.
where line intersect.
Yep. And the definitions of these words are also in your textbook. So if you miss one of them, it's not the end of the world. You can look it up. But I figure it makes more sense for us to discuss these words in context as opposed to not. So then I'm on to my third angle. So it's the same process for finding the angle bisector for my third angle. And if I did everything right, if I come through here, go from the vertex through the intersecting arcs, I should end up in the same exact, oh, look at that. That's a thing of beauty. And so this is called your incenter. The incenter is created by finding the point of concurrency of all of the angle bisectors. And I'll wait a second until you're done, and then we'll talk about some cool properties of the incenter.
No compass.
Incenter is not one of the definition PDs. Is it supposed to be?
Yeah, we're definitely talking incenter today.
There's inscribed.
So inscribed, so in the for the circumcenter, the triangle is inscribed in the circle.
Oh.
And we're gonna have another inscribed moment.
So, just to clarify, inscribed, you basically want to, that's like the definition of the incenter.
No, inscribed is, let's worry about inscribed in a moment, okay?
Alright.
All right, so has everyone found their point of concurrency?
You mean incenter?
The point of concurrency in this case will be the incenter, yes.
Oh, sorry, yeah.
Yeah. I was using a slightly more global vocabulary word for this point. Now, the cool thing about the incenter is this. The incenter is the exact same distance from all three sides of the triangle. Well, what does that mean? I'll show you what that means. So if I, hold on a second. So if I take my compass and check this out. So if I did everything right, I should be able to draw a circle inside the triangle such that it touches, or it is, oh geez, I'm a little bit off. Oh no. So I'm a little bit off here, guys. I am sorry. So why is that? There we go. There we go. Wee-hee. All right.
Mine's a little bit off, but the compass like broke a hole in the paper, so.
That's all right. All right, so notice how all three sides of the triangle are tangent to my circle. Cool stuff. So this circle is inscribed in my triangle. So I'll say this again. The circle is inscribed in the circle.
You mean the triangle?
Sorry, the triangle, thank you. So it's been it's the end of the day. If I look at my first drawing, the circle is circumscribed around the triangle.
So outside.
So circumscribed is saying that the circle is outside of the triangle. Inscribed means the circle is inside the triangle. So circumscribed and inscribed. Again, the circumcenter is made by finding the perpendicular bisectors, and that gives you a point that is equidistant from all three corners of the triangle. The incenter is created by finding the angle bisectors, and the point of concurrency of the angle bisectors happens to be equidistant from all three sides of the triangle. So that would mean that this distance here, I'm going to use a different color, that this distance here, this perpendicular line, is equal to this perpendicular line, which is equal to this perpendicular line. So all three of these distances are equal. And that is the definition of the incenter, a point that is equidistant from all three sides. So Walter and Claudia, how are you doing on incenter and circumcenter?
Good. I'm also just looking in the book for like exact definitions.
That's fine.
What about 521 and 522?
521 is the circumcenter theorem, and the circumcenter of a triangle is equidistant from the vertices of the triangle. That's 5.2. 5.2. Remember, 5.21.
There's 5.1. 5.2 is the incenter theorem. And the incenter theorem simply states that this point of concurrency is equidistant from all three sides of the triangle. So if I were to give you some some labels, let's go A, B, C, X, Y, Z, and I'm going to call the center O. So with the incenter, XO is congruent to YO, which is congruent to OZ.